Now we have to find out the conditions of differentiability of a function. Now let's recall some of what we have already learned. F dash of c, which is nothing but the derivative of the function f of x at the point c, is nothing but limit as h tends to 0 f of c plus h minus f of c divided by h. Now this is the derivative at a point denoted as f dash of c. Now what is the derivative of the function f of x? So we will get back a function which is limit as h tends to 0 f of x plus h minus f of x divided by h. So these are what you have already studied. Okay. Now let's recall a few more things. Now suppose u of x and v of x are functions which are differentiable. Then we have u of x plus or minus v of x. The derivative of this is nothing but u dash of x plus or minus v dash of x. Now if we have the product uv, then the derivative of the product uv is given by u v dash plus v u dash. Now if we have the quotient u by v, the derivative of this is given by v u dash minus u v dash divided by v square, provided v is not equal to 0. Now this is called as product rule due to Leibniz, and this is called quotient rule. Now when we studied differentiation like f dash of c or f dash of x, we have always insisted on provided the limit exists. Now what does this provided that limit exists mean? Now that is what is going to give us the condition for differentiability. Now if f of x is a real function, we need the left hand derivative to be equal to the right hand derivative for the function to be differentiable. Now what is a left hand derivative? Left hand derivative is nothing but minus f of c plus h minus f of c divided by h, which is the left hand derivative. That should be equal to the right hand derivative, which is limit as h tends to 0 plus f of c plus h minus f of c divided by h. Now for any function to be differentiable at a point, it is necessary that its left hand derivative should always be finite and equal to its right hand derivative, and this is the condition for differentiability. Now differentiability at a point. Now we want to find the differentiability of a function in an interval. Now what is the condition for differentiability of a function in an interval? Now if it is differentiable at all points in the interval, so if we take a closed interval a comma b, then it should be differentiable at all points in this interval including a and b, and if it is differentiable in all the points, then you say that the function is differentiable in the closed interval a comma b. The same thing holds good for an open interval where the function has to be differentiable at all points between a and b. So this is the condition for differentiability of a function in an interval.